In today's lesson, we are going to be looking at the cosine ratio. So this is going to be our third ratio that we've looked at. We've already looked at tan and sine, or the tangent and the sine ratio. So we're going to move through this one a little bit more quickly because it, again, like I said before, it's going to look exactly the same. The processes or the processes and the methods, and the methods are going to be identical to the other two lessons that we looked at. The format's going to be the exact same. The only thing is that we are dealing with a different ratio, and as such, we are dealing with a different pair of sides. So again, trigonometry is the study of relationships between sides and angles in triangles. When looking at a right angle or a 90-degree triangles, there are three ratios that we will look at: sine, cosine, and tangent. Now we've already looked at the sine and the tangent ratio in our previous lessons, so we are going to be dealing with the cosine ratio today. As we mentioned before, there are three sides of the triangle that we have to label when dealing with trig or right angle trig. So again, we have our 90-degree angle. We need to have a 90-degree angle because that is going to tell us that it is a right angle. Now across from the right angle is our hypotenuse. Right, so again, the hypotenuse, the longest side, across from the right angle, all different things that we could use to identify it. Now to identify our adjacent and our opposite, again, remember we said before, it's based on the reference angle, or on a reference angle, depending on which one we're given. So it's only two angles that it could possibly be in, either at the top or at the bottom. I'm going to put it back on the bottom this time. So again, remember this is theta, the Greek letter, and it just refers to an angle. In this case, we're going to use it to refer to our reference angle, and this is the angle that we're going to reference when labeling our other sides. Again, across from our our reference angle is our opposite. We think of opposite as being across from, so across from our angle is our opposite, and then A is adjacent. That's the third side. It is the side that's beside my reference angle. Or you could say it's the side between the right angle and the angle. So again, it is helpful to know or to label those sides. That's going to be the first step that we always do. Even though we know in this lesson everything we're going to be looking at is cosine, we want to make sure that we can label the sides properly when we don't know what ratio we're using. So our cosine ratio, so this one is going to be a different pair of sides. This one's going to be adjacent over hypotenuse. So cosine of theta, which again, remember, is an angle, is equal to the adjacent over the hypotenuse, and these two are side lengths. So adjacent over hypotenuse, those are our two side lengths, and then we have our angle for theta. Again, it looks very similar to some of the other ratios we dealt with, except it's just a different pair of sides. So each pair of sides, there's going to be a different ratio. For A and H, adjacent and hypotenuse, it's cosine. Opposite and adjacent, it's tan. Opposite and hypotenuse is sine. So again, we're going to look at how to find side lengths using our cosine ratio. So again, we have our reference angle, 75. We have our hypotenuse. We have our adjacent, and we have our opposite. Again, the two sides that we're dealing with are our hypotenuse and our adjacent, so that we're dealing with cosine. So cosine theta equals A over H. Cosine of 75 is equal to 11 over X. And we had talked before, when the missing piece is on the bottom, we switch and we divide. So X comes up on top. The cosine 75 goes to the bottom. 11 divided by cosine 75 is 42.5 degrees. Again, make sure you are practicing that on your calculator and you are getting the right answer. If you're not getting the right answer, make sure you put it in degree mode. Right? I've mentioned this before in each previous lesson. right? Degree mode. So at the top, you should see either a D or something with a DEG on your calculator. If you see something else, typically it would be an R for radians. You're going to get a different answer. Now, technically, it's not the wrong answer. It's just in the angle in a different unit of measurement. But we want to put it into degrees because that's what we're kind of more comfortable with and what we can kind of visualize a bit more. You will use radians later on in future courses, but for right now, we're going to stick to degrees. For B, again, we have our reference angle, we have our hypotenuse, which is across from the 90 degrees, and we have our adjacent, which is beside our angle. So because it's and then we have our opposite. Again, we're going to label everything just for reference and for practice to make sure we get into those habits. So I'm dealing with A and H, so that means cosine, or the cosine ratio. I'm going to fill in my information. So cosine of 65 is equal to x over 14. And very similar to our other examples, when we had the missing piece on the bottom, or the missing piece on top, sorry, we bring the bottom number up and we multiply. So 14 times cosine 65 will equal x. And 14 times cosine 65 is 5.9. Yeah, we'll round it to 5.9. 5.9 or 6 would be good answers. Two more examples. Again, label our sides first. Opposite, hypotenuse, adjacent. Even if we don't have anything there, it is still a good habit to go through and label those sides. So the only two sides that we're dealing with are A and H. So again, cosine theta equals A over H. Cosine of 58 is equal to 20 over X. Similar to the previous ones, when the missing piece is on the bottom, we switch and divide. So X is equal to 20 divided by cosine 58. And we should get 37.7. So again, just a reminder for a tip or just a key phrase when the missing piece is on the bottom. Switch and divide. For D, again, label our sides. So we have our opposite, adjacent, hypotenuse. If you're struggling with that, labeling the sides, I would suggest label the hypotenuse first. That one is always going to be across from 90 degrees. Label your opposite because that will be across from your reference angle. And then your last side has to be adjacent. So if you go through and kind of those steps, that should kind of simplify it a bit for you. So cosine theta equals A over H. That's our ratio. Cosine of 69 is equal to x over 13. The missing piece is on top, so we bring the bottom value up and we multiply. So 13 times cosine 69 equals x. That's just a calculation, and we get 4.7 equals x. So again, just a kind of a tip, the missing piece on the top, bring up and multiply. Right, so those are the kind of key phrases. Like obviously, there's a little bit more to it, but those should kind of be like the kind of trigger words that you think of. Okay, missing piece on top, bring up and multiply, right? Or even you just remember multiply and kind of work at it from there. Because those are the only two processes or methods for solving for a side length using our right angle trig, right? You've seen the exact same thing in the two previous lessons with the different ratios. For finding angles, it will be the exact same thing as before. We are going to use the inverse, except in this time, instead of pressing tan, or sine, we're going to hit cos after we do after we hit second or shift, depending on what your calculator is. You should see the written words above cosine on your calculator to be the inverse or cosine -1. Again, remember the -1 is not an exponent. It is indicating that it is the inverse. So do not do cosine to the power of -1. It will likely not give you the right answer. So let's just practice using our calculators to make sure that we can enter this in. Again, we should be comfortable with this because we've dealt with these types of questions in our last 2 lessons. It's just the same thing, just a different button. So I bring the cosine over, theta equals cosine -1, or the inverse of cosine, 0.5. And we get that our missing angle is 60. Cosine theta equals 0.471. Again, to get theta by itself, move the cosine over. Becomes the inverse, and 0.471. And again, that just becomes a button on your calculator, or a calculation on your calculator. 62 degrees, or 61.9, but rounded. And then finally, for the last one, even when we have a fraction, inverse of cosine of 5/19. Again, mentioned this before. If you have a fraction, you're more than welcome to divide that value first. So divide 5 by 19, take that decimal and plug it in for with the inverse of cosine. If you're comfortable using your calculator, you could just put 5 divided by 19 in, or the inverse of cosine of 5 divided by 19. We should get 74.74 or 75 degrees. The only thing I would suggest is that when you're dividing your value, so if we take 5 divided by 19, so just off to the side, 5 divided by 19 equals 0. Let me change the color here. 0.6, or sorry, not 6, 0.2631578, and so on. So what you don't want to do is round this to 0.3. Right? We don't want to round too much. I would suggest keeping at least 2 or 3 to 4 decimal places for this step. So 2631 would be good, or 0.263. That would be good. So with what I'm saying is, if I was to take that value and plug it into the inverse of cosine, right, I would want to use the one with more decimals. If you round it too much, you're going to get a different answer, right? Or you might get a different angle. So if I do just the inverse cosine -1 of 0.3, I get an angle equal to 73 degrees. So that's already 2 degrees shorter or smaller than my answer. If I were to do the other one, inverse of cosine of 0.2631, here I get, so cosine, the inverse, 0.2631, we get an angle equal to, and then this one is 74.745 or 75 degrees. So we want to make sure that we are not rounding our decimal too much until we're at our final answer. So let's go through and just practice finding the angle with a triangle. We do have our reference angle, or theta, here. I can label my sides H, O, and A. Again, the 2 sides that we're dealing with are H and A. So this is going to be cosine. So cosine of theta is equal to A over H. Cosine of theta, I don't know what my angle is. That's what I'm looking for. 7/9. Theta equals cosine -1 of 7/9. And I get theta is equal to 39 degrees, or 38.942. Then lastly, same idea, opposite, adjacent, hypotenuse. Dealing with A and H, so that is going to be cosine. Cosine theta equals A over H. Cosine theta, because I don't know my angle, is equal to 32/54. Move the cosine over, it becomes -1. I'm going to do this one by dividing 32 by 54 first. And I get 0.592. So again, I'm going to leave that entire decimal, 0.592. I'm going to leave it as that. Now, I did have a line above, so you might have 5 or 0.592, 592, 592, 592. I'm going to round it to just 0.592, or I guess technically 0.593, because if there was a 592 after, I'm rounding that 2 to a 3. So cosine -1 of 0.593, and we get 53.6, or we'll say 54 degrees. I'll go back and just double check to see if I just did it with a fraction when I get the same answer, and I do, 54 degrees rounded. So those are the 3 trig ratios for right angle triangles. So these are the 3 trig ratios that we're going to use if we wanted to find side lengths or angles when we're given a variety of those combinations. Right? If we're given the angle and a side length, or if we're just given 2 side lengths and we want to find the angle, we should now be able to do that. Right? Depending on what sides we're given or what sides we're using, that will determine what ratio to use. And we'll touch on that a bit more in our next lesson. But right now we can practice the cosine ratio, which will look very similar to all the other ratios, just a different ratio, different button on the calculator, different pair of sides. But the methods for solving for a side length or an angle are the exact same as all the other ratios. Just again, like I said, different ratio and different pair of sides.